We are going to start now lecture 4 of chapter 8 class 9th mathematics quadrilaterals. In this lecture we will discuss about the midpoint theorem. So suppose a triangle is given to us and we are saying that this is the triangle ABC and D and E. These are the midpoints of A, B and AC. Now if we draw a line which passes through this point DE, this is point D and this is point E. We are drawing a line which passes through DE. Then the theorem says that this line is parallel to BC. So to prove this, we are going to do some construction, and it is we have to draw. We have this line over here, and we are drawing a line this C. We are saying this point is F, which is parallel to AB, and it meets this line DE at the point F. This is our construction part for the proof. Now, if we look at the triangle AED and the triangle CEF, if we look at these two triangles, we have these two angles, these are equal to each other because they are vertically opposite angles. These two sides, these are equal to each other, that is AE is equal to EC because E is the midpoint, because E is the midpoint. And the third thing we are saying is that the angle at A, this angle at A and angle at C, these two angles, these are equal because this line AD and CF, these are parallel to each other. We are talking about these two lines, this line AD and this line CF, these are parallel to each other, and this AC is the transversal. So we are having angle A is equal to angle C. So what we get is that these two triangles, the triangle ADE we are talking about and the triangle CEF we are talking about, both these triangles, these are congruent to each other by ASA criteria. So what we get from this is that AD, that is equal to CF. We are having this AD, we are talking about this side AD, that is equal to CF, and this AD length, this is equal to DB because D is the midpoint. So we are saying that this length is equal to this. So what we get is, when we are talking about this figure over here, we are saying this is D, B, C and F. We are saying these two lines, these are parallel, these two lines are parallel and these two lines are equal to each other. So what we get is that this figure is this BCFD is a parallelogram. So this gives us that these two sides are also parallel to each other. This is what we have to prove. Now the next thing that we have to prove is that this line, that this length DE, that is equal to 1 by 2 times BC. This is mentioned over here and equal to the half of it. This line, it is parallel to it and it is equal to half of it. Now we have already proved that these two triangles, the two triangles I am talking over here, these two triangles we are talking about, it is ADEFC. In these two triangles, we have proved that these two triangles, they are congruent to each other. So we have is this side AD is equal to FC. This we have already seen over here. And the next thing we have is this side AE is equal to EC. And the third thing we have is that the DE is equal to EF. So we have DE is equal to EF. Suppose the length of BC is X. This point E is over here. The length of DF is also X because DEF is a BCFD is a parallelogram. So E is the midpoint over here. It means this distance is X by 2. and this is what we have to prove. That again I am talking about what the result says is that a triangle is given to us. We have taken the midpoint D and E over here. We have drawn a line passing through this D and E, and what we are saying is that this line is parallel to this DE is parallel to this BC. This is parallel, and the length of this DE is half of BC. Next is the converse of midpoint theorem. So it says that the line drawn through the midpoint of one side of a triangle parallel to the other side bisects the third side. So converse means we are saying now a triangle is given to us, and the midpoint of one side is given to us. So this point is the midpoint of A, B. This is C. Now we are drawing a line parallel to, we have drawn a line parallel to BC. Then we have to prove that this point E, we have to prove that E is midpoint of BC. In the theorem we were saying that D and E, these are the midpoint, and this line is parallel. Now we are having that DE is parallel to BC, then we have to prove that E is the midpoint. So we are saying that DF, F is the point that we have seen in our previous theorem. F we have obtained by drawing CF parallel to AB. F is the point where this CF, this line drawn from C parallel to AB, it intersects the line DE. So we are saying that this DF, we have this DF, it is parallel to BC. This is given to us, and by our construction we are saying that this AB is parallel to FC. So what we get is that this figure over here, this BCFD is a parallelogram. Now we are saying that this CF is equal to, this CF is equal to BD, and BD is equal to AD. This is already given to us because D is the midpoint. This is given to us. So we are saying that this length DB and AB, these are equal, and these two lengths, these are equal. So again, if we look at these two triangles, we are talking about ADE and ECF. What we have now is that this angle at E, these two angles, these are equal. We have proved that this side is equal to this. These three sides AD, DB and FC, these are equal to each other. Now next thing we have is this line AD and this line FC, these are parallel to each other. This AC is the transversal over here. If this is the transversal, it means this angle at A and this angle at C, both these angles, these are equal to each other. So what we get is from ASA criteria, we are saying that both these triangles, these are congruent to each other. Now if these two triangles, these are congruent to each other, then we have is that this AE length, this is equal to EC length. This is by, these two are equal. This is by CPCT, and this is what we have to prove, that E is the midpoint of AC. In this question we are given that D, E and F, these are the midpoints of the sides B, C, C, A and A, P of a triangle ABC. We have to prove that, and further it is given that ABC is an equilateral triangle. ABC is an equilateral triangle. What we have to prove is that this triangle DEF is an equilateral triangle. This DEF is an equilateral triangle. We have to prove this. So we are saying if the length of this BC is X, then the length of this FE is x by 2. Similarly, if this length is x, we are saying this, why this length is, we are saying BC is there, F is the midpoint of AB, E is the midpoint of AC. So by midpoint theorem, we are saying that these two sides, these are parallel. We have two conditions over here, that these two sides, these are parallel, and length of this is half of this length. Similarly, when we are considering the side AC and FD, we are saying if the length over here it is x, then this length is x by 2. If AB length is x, then this length is x by 2. So what we get is that the length of all these three sides, if the length of the AB, BC and CD is x, then we have the length of D, E, F and FD, it is x by 2. So if the side length of all these sides is x by 2, it means it is an equilateral triangle. Next is a triangle ABC is given to us, and it is given that D, E, F, these are the midpoints of the corresponding sides, and we have to prove that these four triangles we are talking about, this ADF, next we are saying DBE, next triangle we are talking about is FEC, and the fourth triangle is DEF. These four triangles we are saying these are congruent to each other. Now to prove this result, we are talking about another result. We are saying, suppose a parallelogram is given to us. This is A, B, C, D, and we are drawing a diagonal over here. This is the diagonal over here. Then we are saying the two triangles, this ABD and the triangle CBD. These two triangles, these are congruent to each other. That is, the diagonal of a parallelogram divides it in two triangles which are congruent to each other. So how we are going to prove this is that this side is common over here. For this parallelogram, we are saying this side is common. These two triangles we are saying. Next, this AB and BC, these are parallel. We are talking about these two lines. These two are the parallel lines over here. And this is the transversal we have drawn. So what we get is that the angle over here at D and this angle over here at C, these two angles, these are equal to each other. Now by the property of parallelogram, we know that this angle and this angle, these two angles are also equal. So by AAS axiom or AAS criteria, we are saying these two triangles, these are congruent to each other. So what we get is that a parallelogram, this is mentioned over here, that any diagonal of a parallelogram divides it into two congruent triangles. Now we come to the proof of this theorem. We are saying that this point D, this point we are talking about, this point D and this point F, these two are the midpoints. So what we get is that this line DF, this is parallel to BC. Similarly, this AD and FC, these are parallel to each other. These two lines are also parallel to each other. So what we get is, if we are talking about this figure over here, this portion over here, it is DFEB. This figure we are talking about. In this figure, we are saying this is the diagonal. This DF is parallel to BE and BD is parallel to EF. We are saying in this figure, DF and BE, these are parallel. Then DB and FE, these are parallel. So it means this is a parallelogram. We can use this result in this proof over here. So what we get is that DBE, this triangle, is congruent to DFE, this triangle. Similarly, if suppose I am saying, I am talking about this line AF, we are talking about this line AC and this line over here. These two lines, these are parallel to each other. DF and EC are parallel to each other. So I am talking about this portion. We are saying it is DFCE. In this, these lines, these are parallel to each other. These lines are parallel to each other. So we get, if we join these two, we are saying these two triangles, these are congruent to each other. Similarly, we can prove for the other triangles, and we can see that all these triangles, these are congruent to each other. In this question, it is given to us that ABCD is an isosceles triangle. It means we are talking about the two sides are equal. It is given that AB and AC, these two sides, they are equal to each other. Then next it is given that these points F, E and D, these are midpoint of these sides, corresponding sides. We have to prove that AD, this line AD, this is perpendicular to FE. This FE is there. And we have to prove further that AD is the bisector of FE. That is these two lines. These two lines, these are equal. So we have done the construction over here. That is, we are saying the point where the line AD and FE they meet, we are naming it as M, and we are joining the lines D and E. These we are talking about. We have joined these points F, D and E. So now what we have is that this DE length we are talking about, this DE length, and if we look at this AB length, suppose this length is Y, then this length is Y by 2. Similarly, this length AC is there, this length is Y, then this length is Y by 2. So what we have now is that these two lengths, these are Y by 2, this length is also Y by 2. So what we see, if we look at this figure over here, A, F, D, E, all four sides they are of length Y by 2. It means this is a rhombus. We are saying these sides, these are parallel to each other. These are by midpoint theorem. We are saying all these sides, these are Y by 2. So it means this is a rhombus. And we know that the diagonals of a rhombus, they bisect each other at right angles. We are saying the diagonals of a rhombus, they bisect each other at right angles. So what we get is that this AM and EF, we are talking about this AM and EF, these are the diagonals, so they bisect each other at right angle. So this is what we have to prove, that this angle is 90 degree and these two lengths, these are equal. Now in this next question, we are saying ABC is a right angle triangle. This is given to us that this triangle ABC, this is right angle triangle. It means this angle we are saying this is 90 degree, and D is the midpoint of BC. This D is the midpoint. So we are saying this AD and DC, these two lengths, these are equal. We have to show that DA, DB and DC, these three are equal. We have to prove that this length is also equal to these two lengths. So to prove this, we are going to do some construction over here. We are saying that we are joining the points D and E. Basically, we are not joining the point D and E. We are saying that we have drawn a line parallel to BC from the point D. This is our point D, and we have drawn a line parallel to BC from the point E, D. Now, if these two lines, these are parallel, we are saying these two lines, these are parallel. D is the midpoint. So what we get is E is the midpoint of AB. Why? It is the converse of the midpoint theorem. It is by this E is the midpoint of AB by converse of midpoint theorem. So what we get is that this EA and EB, these two, these are equal in length. Now the next thing we are going to do is we are talking about two triangles. One is this triangle AED. We are talking about this triangle. This is AED. And second, we are talking about the triangle EDB. Second triangle we are talking about, it is EDB. EDB. Now in these two triangles, we have this angle over here, this angle at E, it is 90 degree. Why? Because we are saying this BC length we are talking about, this BC line we are talking about, this ED line we are talking about. Both these lines are parallel to each other and AB is the transversal. So if angle B is 90 degree, you will get angle E is also, this angle E is also 90 degree and this angle is also 90 degree. This is 90 degree, this angle we are talking about, this AED angle we are talking about, it is 90 degree because it is the corresponding angle. And this is 90 degree because of the linear pair property. That these two angles, the sum of these two angles should be 180. So this angle is 90 degrees. So we are saying this angle at E is 90 degrees. Next thing, we have already seen that AE is equal to EB. This is by midpoint theorem. That is AE is equal to EB. This ED is the common side over here. So both these triangles, these are congruent to each other. And if these two triangles are congruent to each other, then what we get is that this AD and BD, they are equal. We are saying this AD and BD, these are equal. So we already have AD is equal to DC. We have AD is equal to BD. So combining these two results, we get the final answer that AD is equal to DB is equal to DC. Now next, we are given ABCD is a parallelogram. This ABCD is a parallelogram. E and F are the midpoints. This E is the midpoint of AB and F is the midpoint of DC or CD we are saying. Then we have to prove that the line segments, these line segments we are talking about, this CE and AF, these two line segments, they trisect the diagonal BD. Trisect the diagonal BD means we have to prove that this length DQ, that is equal to QP, that is equal to PD. When we are saying bisect, bisect means it is dividing it in two equal parts. Trisect means it is dividing it in three equal parts. So now we are talking about the lines. We are saying AE, this AE and FC, these two lines are parallel to each other because ABCD is a parallelogram. If the length of this side is X, then the length of this side is X because ABCD is a parallelogram. It means length of FC is also X and length of AE is X because E and F, these are the midpoints. So what we get is, if we look at this figure over here, we are talking about A, E, C, F. We have these two sides, their length is X, X by 2, X by 2. Its length is X by 2 and both these sides, these are parallel to each other. So what we get from this is that this AFCE is a parallelogram. If AFCE is a parallelogram, it means this side AF, this is parallel to the side EC. So this gives us that this AQ, this much portion, and EP, this much portion, these two lines, these are parallel to each other. So if we draw this triangle over here, we are talking about this is AQB, and we are drawing this over here. This is the point P and E. We are saying these two lines, these are parallel to each other, and this E is the midpoint over here. It is given to us that this E is, this distance is X by 2 and this distance is X by 2. Now we have this E is the midpoint. These two lines, these are parallel. So by the converse of midpoint theorem, we are saying P is the midpoint of QB. So if P is the midpoint of QB means we are having QP is equal to PB. Suppose it is equal to Y. We are saying this length is Y and this length is Y. Now consider the triangle. We are saying DPC over here. We are talking about this triangle. It is DPC. This is DCP. We are having a line over here that is QF. We are talking about this triangle over here. This is DPC. And this is the line QF over here. So we are saying in this triangle, we have these two lines. These are parallel to each other because AECF is a parallelogram. This F is the midpoint over here. This length is x by 2. This length is x by 2. So what we get is that Q is the midpoint. Now, previously we have seen that the value of this QP, that we are saying it is y. If this is the midpoint, then value of DQ is also y. So finally what we get is that DQ is equal to QP is equal to PB. All these three lengths, these are equal. So we get that the diagonal AD trisect these two lines. The next question we have that a quadrilateral is given to us ABCD. This is the quadrilateral ABCD, and the midpoints of this quadrilateral P, Q, R and S are given to us and they are joined. We have to prove that this PQRS is a parallelogram. Now we have done the construction over here. It is, we have joined A and C. We have joined this A and C. Now if we look at the triangle ABC, we are talking about this triangle. This is ABC. This triangle we are talking about. We are saying P and Q, these are the midpoints of A, B and BC. So what we get is that PQ is parallel to AC. Similarly, if we are looking at the triangle ACD, then S and R are the midpoints of the sides AD and CD. So what we get is that this SR is parallel to AC. So first we have obtained that PQ is parallel to AC. Second we have obtained is SR is parallel to AC. Next, if the length of AC is x, we have the length of SR is x by 2 and length of PQ is x by 2. So what we get is that SR is parallel to PQ and SR is equal to PQ is equal to x by 2. So we get that PQRS is a parallelogram. In this question, it is given that ABCD is a parallelogram. This ABCD is a parallelogram, and E and F, these points E and F, these are the midpoints of AD and BC, and these 2 points we have joined, E and F we have joined. We have to prove that this line EF we are talking about, it is parallel to AB. We have to prove EF is parallel to AB, and second thing we have to prove is that this EF length, that is equal to half of AB plus CD. So to prove this, we are going to do the construction over here, and we have joined the points D and F, and we have produced it to meet the line AB at P. This construction is shown over here, that we have produced this line DF and it meets over here at this AB at P. This is the construction part that we have to do. Now, if we consider the triangle, we are talking about the triangle DCF. This DCF, and second we are talking about is PBF. We are talking about these 2 triangles over here. So what we have is that these 2 angles, these are equal because these are vertically opposite angles. Next we are saying that this line, these lines we are talking about, that is this DC and this BP, these 2 lines, these are parallel to each other. So what we get is that this angle C is equal to angle B and this angle P is equal to angle D. All these angles, these are equal to each other. Next thing that is given to us is that f is the midpoint over here. So we are saying if this length is x, then this length is also x. So what we get is that these two triangles, these are congruent to each other by ASA criteria or AAS criteria. You can use any one of these two. So what we have now is that DF, this length DF, that is equal to the length PF, that is equal to this length, and the length DC, this length DC, that is equal to the length BP. Now if we consider the triangle, this APD, this larger triangle we are talking about, this is DAP we are saying. In this triangle what we have is, this E is the midpoint over here, this point E, this is midpoint of AD, and this F is the midpoint of DP. This thing we have already proved, that this DF and FP, these are equal in length, so F is the midpoint of DP. So what we get is that this line EF, this is parallel to AB, and the second thing that we will get is that the length of this, if this length is y, then this length is 2 times y. It means we are talking about that EF, that 2 times EF, that is equal to AP. AP length we can write it like AB plus BP. This BP and DC, these are equal, so we will get it is AB plus CD. So the final answer we will get it is EF is equal to 1 by 2 times AB plus CD. This is our final answer, that EF length, that is equal to 1 by 2 times AB plus CD. In this question, this is just like the previous question. The only difference is that in the previous question it was given that E and F we are talking about, we were given that this point E is the midpoint over here, and in the previous question it was given that F was the midpoint. But now we are given that E is the midpoint, and this line EF is such that these two lines, these are parallel to each other. It means these 3 lines, these are parallel to each other, and we have to prove that this F is the midpoint. We have to prove that this F is the midpoint. In the previous question this was given, and we have to prove that these lines, these are parallel. Now it is given that the lines are parallel, and we have to prove that it is the midpoint. So in the previous question we have joined the point D and F, we have joined the point D and F, and we have extended it to the point P where it meets AB. In this question we have joined the points D and B. We join these 2 points, and the point where it intersects the line EF, it is M. Now if we look at the triangle over here, we are talking about this triangle DAB. We have this E is the midpoint, this is given to us, this is midpoint, this is given. These 2 lines, these are parallel. So by midpoint theorem we are saying this M is the midpoint of DB. Now consider the triangle, this triangle DCB. M is the midpoint over here, we have already proved this. Next thing we have is this line M, F and DC, these are parallel. Again using midpoint theorem we get F is the midpoint of BC, and this is what we have to prove in our first part, that F is the midpoint of BC. Next thing we have to prove is that this EF is equal to 1 by 2 times AB plus DC. So again if we look at the triangle DAB, by midpoint theorem we are having EM, that is equal to 1 by 2 times AB. We are saying this EM and this AB, it is 1 by 2 times AB, and MF is equal to 1 by 2 times DC. This AB, this is DC. Now we have to find the total length over here, that is EF. So we get EF is equal to 1 by 2 times AB plus CD. This is what we have to prove. Now the next question, we have the line segment joining the midpoints of the diagonal of a trapezium. We are saying that a trapezium ABCD, this is given to us. Then we have two diagonals over here, one is AC and second is BD. M is the midpoint of AC and N is the midpoint of DC, and we have joined these 2 points M and N. We have to prove that the midpoint of the line segment joining the midpoint of the diagonals of the trapezium is parallel to the parallel side and equal to half of their differences. So what we have to prove is that these three lines, these are parallel to each other, and this length of MN, the length of this MN, that is equal to half of the differences of these two lines, that is AB minus BC. So to prove this, we are going to do some construction over here, and we have joined the point C and N and produced it to the point E so that it meets at B. This construction is shown over here. We have joined the points C and N. These points C and N are there, and we have extended this line to meet it AB at E. Now we consider two triangles over here. One is the triangle we are talking about, it is CDN, and second triangle we are talking about over here is EBN. We are talking about these two triangles. Now in these two triangles we are saying that N is the midpoint of DB. It means this length and this length, these two lengths, these are equal to each other. These two lengths, these are equal to each other. These angles, these are equal to each other. These are vertically opposite angles. And the next thing we have is this angle D and this angle B, it is equal. This angle E and this angle C, it is equal. So we are having all the three angles, they are equal. The corresponding angles over here. We are saying this angle N is equal to this angle D is equal to angle B, and angle C is equal to this angle C we are talking about, and E we are talking about. Both these angles, these are equal. So it means these two triangles, these are congruent to each other. Now if these two triangles, these are equal, it means these sides are also equal. So sides are equal means we are saying this length DC, that will be equal to the length EB, and the length CN, that is equal to the length NE. These lengths, these are also equal. Now we look at the triangle we are talking about, that is ACE. We are talking about this triangle. This triangle is ACE. We have 2 points over here. One is the point N and second is the point M. Now from the question we have this AN, M and MC, these are equal because M is the midpoint of diagonal AC. Next we have proved that this N is the midpoint of CE. So if M and N, these are the midpoints over here, what we get is that this MN, by midpoint theorem we have MN is parallel to AE. This is our first part of the theorem of this question, and the second thing we have to prove is that MN is equal to half of AB minus DC. So from the midpoint theorem further we have is MN is equal to 1 by 2 times AE. Now 1 by 2 times AE, we can write AB minus EB. Next we have is this EB, this length EB, this is equal to the length DC. So this is what we have to prove, that MN is equal to half of AB minus DC. Now in this question a triangle ABC is given which is right angled at C. we are talking about this triangle. This is ABC is given. It is right angled at C. A line through the midpoint P of the hypotenuse AB. This P is the midpoint of the hypotenuse. We are saying this is the hypotenuse. So we are saying these two lengths, these are equal. These two sides, these are equal. And parallel to BC intersect AC at M. We are saying these two lines, these are parallel to each other. From the point P, that is midpoint of AB, we have drawn the line parallel to BC and it intersect AC at M. We have to show that M is the midpoint of AC. So M is the midpoint of AC. This is obvious from the midpoint theorem. We are saying P is the midpoint of AB. These two lines, these are parallel to each other. So what we get is that M is the midpoint of AC. Second thing we have to prove is that MP is perpendicular to AC. Now we are saying this line PM and CB, these are parallel to each other. These two lines, these are parallel to each other. This AC is the transversal over here. So if this angle is 90 degree, then this angle is also 90 degree and this angle is also 90 degree. So what we get is that this PM is perpendicular to AC. Why these angles? These are co-interior angles. We are talking about this angle over here. Why these two angles? These are why this angle PMC is 90 degree? Because it is co-interior to BCM. So we get these two angles. This PM is perpendicular to AC. Now next we have to prove is that this CP, that is equal to AP. So it means first of all what we have to do, we are joining these points C and P. We are joining C and P means we have joined these 2 points C and P, and we are saying the CP is equal to AP. Now look at the triangles over here. We are saying it is PAM. We are talking about 2 triangles. One is PAM and second triangle we are talking about is PMC. We are talking about these 2 triangles. In these 2 triangles we are saying this angle is 90 degree. This side is common. This side is common over here. M is the midpoint. It is given to us. It means AM and MC. This M is the midpoint. This we have proved in our first part. So we are saying this AM and MC, these are equal. It means these 2 triangles, these are congruent to each other. If these 2 triangles, these are congruent, it means this AP length, that is equal to PC length. Now the second thing that is we already have is that P is the midpoint of AB. So we are saying if this length is X, this length is X, this is X. So what we get is that CP is equal to AP is equal to half of AB, because P is the midpoint of AB. Now in this next question we are given a parallelogram ABCD and it is given that P is the midpoint of DC. It means these 2 sides, these are equal. Then next it is given Q is the point on AC such that CQ, this length we are saying this is CQ, this is 1/4 times AC, this whole length, it is 1/4 times this whole AC. Also we are saying that this PQ when produced meet BC at R. We have joined the points P and Q and it meets this BC at point R. We have to prove that R is the midpoint of BC. So to prove this we are going to join first of all B and D, and the point where it intersects this AC is the point O. Now what we have is that AO is equal to OC. Why? Because we know that diagonals of a parallelogram bisect each other. So what we are saying is that this length AO and this length OC, these 2 lengths, these are equal. Now we are saying that this whole length AC, suppose it is equal to X. Then we are saying this OC length is equal to 1/2x. and this CQ length is equal to 1 by 4x. This is given in the problem. So if we look at the triangle CDO, we are talking about the triangle CDO. What we have now is that P is the midpoint of DC and Q is the midpoint of OC. We are saying if this length is 1 by 4x, this length is also 1 by 4x. So it means both these lines, these are parallel to each other. And if now we consider the triangle COB, now we consider the triangle COB. Now in this triangle, I am talking about in this second figure we are talking about COB triangle. What we have now is that Q is the midpoint. Q is the midpoint. Next thing, we have already proved that these lines, these are parallel to each other. These lines, these are parallel to each other. So from this what we get is that R is the midpoint of BC, and this is what we have to prove. Next, we are given a triangle ABC and AD is the median. We are talking about this triangle ABC, and we are saying this AD is the median. AD is the median means that this D is the midpoint of this BC. These are equal. We are saying when BE is produced, meet AC in F. This E is the midpoint of AD. This E is the midpoint of AD, and when this BE is produced, it meets this point F over here. We have to prove that this AF length, we are talking about this AF length, this is 1 by 3 times AC length. This AC length is there. This AF is 1 by 3 times AC. So we have done the construction over here, and we have joined these points. We have drawn from this point D, we have drawn a line parallel to BE, and it meets this line AC at P. So now we are talking about two triangles. First we are talking about the triangle ADP. We are talking about this triangle, and second we are talking about the triangle FBC. So when we are talking about the triangle ADP, what we get is, we know that we have is this E is the midpoint, and by construction part we are saying these two lines, these are parallel to each other. This EF and DP, these are parallel to each other. So this gives us that F is the midpoint of AP. You get that F is the midpoint of AP. Similarly, when we are talking about the triangle ABC, we are saying D is the midpoint. Why? Because AD is the median. These two lengths, these are equal. By construction, this DP is parallel to this BF. This line, these two are parallel. It means P is the midpoint of FC. P is the midpoint of FC. So what this thing means is suppose I am saying this length AF is X, then this F is the midpoint of AP. It means this length is also X, and P is the midpoint of FC. It means this length is also X. So total length of AC is equal to 3x, and what we have to calculate is, we have to calculate the value of AF. We are saying it is X. So the final answer we will get, it is that AF is equal to the value of X. From this you will get, it is 1 by 3 times AC. You put it over here, it is 1 by 3 times AC. So we get AF is equal to 1 by 3 times AC. Next we are given a trapezium ABCD. We we are talking about this trapezium over here, A, B, C, D. Then we are talking about these diagonals over here. This is A, C and B, D. Now we are saying this P is the midpoint of AB, R is the midpoint of BC. This point S we are talking about, this S is the midpoint of AC, and this point Q we are saying, this point Q, this is the midpoint of BD. We have to prove that this figure over here, we have joined this point R, S, P and Q. We have to prove that this figure over here, this figure, this is a rhombus. We have to prove this, that this figure is a rhombus. That is, we have to prove all the sides they are equal and they are parallel to each other. Now if we consider the triangle, we are saying BDC. We are talking about this triangle BDC. So in this triangle we have Q and R, these points Q and R, these are the midpoints of side BD and DC. So what we get is that these two lines, these are parallel. If the length of this side is x, then the value of this is x by 2. Similarly, if we consider the triangle ABC, so in this triangle we are saying S is the midpoint of AC and P is the midpoint of AB. So what we get is that the side SP, this is parallel to the side CB, and this length is x by 2. So what we get is that these opposite sides over here, these are equal, x by 2, and these two sides, these are parallel to each other. So it means this PQRS is a parallelogram. So the only thing that we are left to prove is that other sides are also equal in length. So to prove this, we are given that in the question it is given that the sides AD and BC of the parallelogram, they are equal. So what it means is that this length is also, this AD length is x. So as we have proved in the case of SP and QR, similarly we can prove that this length S, this line SR, this is parallel to AD and the length of this line is x by 2, and this PQ is parallel to AD and length of this line is x by 2. Both these are parallel to these lines, these are parallel to AD. We are saying these lines, these are parallel to BC. So both these are parallel, and all the length of all these sides, this is x by 2, x by 2, x by 2 and x by 2. So finally what we get is that PQRS has all sides equal and opposite pair of sides, they are parallel. So PQRS is a rhombus. Now in this next question, it is given that ABCD and PQRC, these are rectangles. We are talking about this ABCD and this PQRC, these are the rectangles where Q is the midpoint of AC. We have joined this A and C, and Q is the midpoint of AC. We have to prove that this DP and PC, these are equal. We have to prove that this DP and PC, these are equal, and we have to prove that this PR, this length PR over here, this PR, that is half of AC. So first thing we see from this is that these two figures, these are the rectangle it is given to us. So what we have is that this angle is 90 degree and this angle is 90 degree over here. So what we get is that this QR, these two lines, these are parallel, then PC and AB, these is parallel. So all these three lines, these are parallel to each other. Now look at the triangle ABC. When we look at this triangle ABC, it is given that Q is the midpoint of AC. This is given in the problem, this is given to us. Then the next thing we have is that the line we are talking QR, this is parallel to AB. So we have is R is midpoint of BC. We get R is the midpoint of BC. Similarly, we are saying this line PQ, AD and BC, these three are parallel to each other. Now consider this triangle DBC over here, this triangle. So R is the midpoint, P is the, we are talking about these two lines, this QP and BC, these lines, these are the parallel lines. Q is the midpoint over here of BD. So what we get is that P is the midpoint of this, P is the midpoint of DC. Now in the triangle, in the same triangle we are talking about, that is DBC we are talking about. In this triangle, we have P is the midpoint of DC and R is the midpoint of BC. It means what we get from this is that this line PR and this line DB, they are parallel to each other. And further we have DB, that is equal to 1 by 2 times PR. This is 2 times PR, not 1 by 2 times PR, it is 2 times PR. And we know that the diagonals of a rectangle, they are equal in length, and this DB will be equal to AC. This DB will be equal to AC, and this is what we have to prove, that this PR is equal to 1 by 2 times AC. In this question, we are given a triangle ABC and DEF, these are the midpoints of the corresponding sides. We are talking about, this is the triangle ABC and these points are given to us D, E and F. These are the midpoints of BC, CA and AB. Next it is given that if BE and DF, we are talking about, B is over here and DF is over here. If these 2 points, these are intersecting at X, and second thing that is given is CF and DE. We are talking about, this is CF and this is DE. These two are intersecting at Y. We have to prove that XY means this length XY, this is 1 by 4th of BC, this length C. So to prove this, we are considering the triangle ABC. In this triangle, we are saying E and F, these are the midpoints. So what we have now is, we are talking about these two lines. One is the line BC and second is the line F. These two lines we are talking about. So for these two lines, we are saying F and E, both these are the midpoints. If these two are the midpoints, it means this line FE is parallel to BC. And next thing that we get is, if the length of BC is X, then the length of EF is X by 2. So both these lines are parallel and this length is X by 2. Now if we consider the triangle, in place of triangle we are talking about, we consider the parallelogram. Why parallelogram I am saying? Because if this length is X by 2, we are saying D is the midpoint, this length is X by 2. Now look at this figure over here. We are saying B, D, E, F. This figure we are talking about. I am drawing it over here. It is B, D, E and F. This is a parallelogram because these two sides, these are parallel to each other and their length is X by 2 and they are equal in length. So it means it is a parallelogram, and we know that the diagonals of the parallelogram, they bisect each other. So if we look at the diagonals of this we are joining over here, this is BE and this is the point DX. So what we get is, this is the midpoint of this. So these two lengths we are talking about, that DX and XF, these two lengths, these are equal. Similarly, if we are talking about the parallelogram DCEF, then Y is the midpoint of the diagonals. if y is the midpoint of the diagonals, we get that y is the midpoint of D. These are equal to each other. These two lengths, these are, that is dy is equal to y e. So if we look at now, we look at the triangle D E F. We are talking about this triangle. In this triangle over here, D E F. In this triangle, we are saying this dx length that is equal to xf length, and this dy length that is equal to ye length. It means this x and y, these are the midpoints over here. If these are the midpoints, the length of fe, we are saying it is x by 2. So what we get, that one thing we get is that these two lines, these are parallel to each other, that is xy is parallel to fe. And second thing that we will get, it is xy, the length of this line xy, that is equal to half of fe, that is equal to half of fe is half of bc. This is what we have to prove. Half into half is 1 by 4. So we get that the length of xy, that is 1 by 4 times bc. Now we have is the intercept theorem. So it says that we will see what the definition of intercept is. We are given three parallel lines. And we are saying a transversal is there, that is intersecting over these three lines. So intercept, we are talking about this distance. If I am talking about, say this is the line N, this is M, this is L, this is the point C, B, A, this is transversal T. Then this length BC, this is the intercept. Then this length AB, this is the intercept. The length of this AB, this is the intercept. So what intercept theorem is saying, if three parallel lines are there, L, M, and these are three parallel lines, and a transversal is there. We are talking about one transversal, say P, and there is another transversal Q. There are two transversals over here. For this transversal P, we are saying the length of AB, this length of AB, that is equal to the length of BC. Both these lengths, these are equal. Then we are saying that on this transversal Q also, these lengths will be equal. That is, we have to prove that PQ is equal to QR. To prove this, we are doing some construction over here. What construction we have done? We have joined A and R. We have joined these points A and R, and this point where it intersects with the line M, that we are saying it is the point K. Now look at the triangle over here. In this figure we are talking about, this is AB, or we are saying ACR triangle we are talking about. So in this triangle, we are saying that these two lines are parallel to each other. It is given to us. AB and BC, these are equal. It means B is the midpoint. So these two lines, these are parallel. B is the midpoint. So what we get is the K is the, this is what from these two things, that these are parallel and this is the midpoint. We are getting that K is the midpoint of here. Now consider the triangle ARP. In this triangle, we have R is the midpoint. This K is the midpoint. Again, these two lines, these are parallel. Then this gives us that Q is the midpoint. And this is what we have to prove, that the intercepts made by them on one transversal are equal to the intercept made by them on any other transversal are also equal. That is, if AB is equal to BC, then PQ is equal to QR. Next, we are given 2 points A and B which lie on the same side of the line XY. So we are saying a line XY is given to us. This is our line XY, and these are the points A and B which lie on the same side of the line xy. Next, it is given that AD is perpendicular to this line. AD is there. This is perpendicular to xy, and BE is there. It is perpendicular to xy, and C is the midpoint of AB. This point C, this is the midpoint of, it is given that this is midpoint of AB. That is, this AC and BC length, these are equal. We have to prove that CD and CE, both these lengths, these are equal to each other. So to prove this, we have done the construction, that is, we have drawn the perpendicular from point C on the line xy. This perpendicular we are talking about, CM, we have drawn. Now if we look at these three lines AD, CM and BE, all these three lines, these are parallel to each other. These three lines we are talking about, these three lines, these are parallel to each other, because AD, this angle is 90 degree, this angle is, this is perpendicular, this is perpendicular. So all these three lines, they are parallel to each other. And the line, if we look, that is ABC, this line A, this is transversal for these three lines. We are talking about three lines. One is the line this AD, second is this CM, and third is this BE. For these three lines, we are saying this is a transversal and this is also a transversal. Now it is given to us that this AC and CB, these are equal. If these two are equal, then these values DM and ME, these are also equal to each other. This is by intercept theorem. Now if we look at the triangle, one triangle we are talking about is CDM, and second triangle we are talking about is CEM. These two triangles we are talking about. In these two triangles, we are saying this DM and ME, these two are equal. This side CM, this is common, and this angle over here, it is 90 degree, and this angle over here, it is 90 degree. So by SAS axiom, these two triangles, these are congruent to each other. This is mentioned over here that these two triangles, these are congruent to each other. If these two triangles, these are congruent to each other, what we get is that these two sides, that is CD and CE, these are equal to each other, and this is what we have to prove. Next, it is given that the points M and N divide the side AB of a triangle ABC. A triangle ABC is given to us. This is the triangle ABC, and these are the points M and N. This divided in this side AB in three equal parts. So it is given that these three lengths, these are equal to each other, and the line segment MP NQ, you have drawn these line segments MP and NQ are both parallel to BC. This is given to us that these are parallel to each other. Then we have to prove that P and Q divide AC in three equal parts. We have to prove that these three lengths we are talking about, that this A, P, PQ and QC, these are equal. So first of all, we have done the construction over here, that is through A we have drawn a line XAY parallel to BC. This line we are talking about, that through A we have drawn a line which is parallel to BC. Now look at these three lines. We are talking about the line XY, MP and NQ. These three lines we are talking about. For these three lines, this AB is the transversal and this AC is the transversal. These two are the transversal. On this transversal A, we are talking about, this is our line XY, this is MP, this is NQ. This is one transversal and this is the second transversal. This is point A. This is line XY. These are our points M and P. These are our points N and Q. Now, for this transversal, we are saying it is given that the length AM and MN, these are equal to each other. Now this is also a transversal over here. So by intercept theorem, we are saying that these lengths are also equal to each other. That is AP is equal to PQ. You get that? AP is equal to PQ. Next, if we consider three parallel lines again, one is the line we are saying PQ, this line PM, second is NQ, and third is BC. For these three lines, we are saying this AB is the transversal and this AC is the transversal. So I am drawing these three lines again over here. These are the three lines we are talking about, and these are the two transversals we are talking about. This point is MP, NQ, and BC. This point we are saying it is A. So for these three lines, we are saying this is the transversal over here, and it is given that these two lengths, these are equal to each other. Then by intercept theorem, we are having this PQ is equal to QC. So PQ is equal to QC. In the main figure we are drawing this. So from this what we get is that all these three, that is AP, PQ and QC, these are equal to each other. Now next is E and F are respectively the midpoints of non-parallel sides A, D and BC of a trapezium ABCD. We have to prove that EF is parallel to AB. The same question we have also done previously, but now we are using the intercept theorem over here. In the previous case we have used the midpoint theorem. How we have proved this? We have considered the trapezium like this, and these are the lines that is given to us. The construction that we have done over there, it was in this form. Then we have considered one triangle this. In this triangle we are saying this point and this point, these 2 points, these are the midpoints of this triangle. If these two are the midpoint of this triangle, then these two sides, these are parallel to each other. This proof we have already done. This is another kind of proof. So now what we are saying is that we consider that the line EF, it is not parallel to AB. We have to prove that this line EF we are talking about, this EF, this is parallel to AB. We are considering that this line is not parallel to AB. So if this is not parallel to AB, we are saying we draw a line EG which is parallel to AB. We have drawn this line EG which is parallel to AB. These two lines we are talking about. So what we get now is that these three lines, that is the line AB, EG and DC, these three lines are parallel to each other. Now look at this intercept over here and look at this intercept over here. We are talking about these two intercepts. What we get is, what we are given is this DE and EA, these are equal because it is given that E is the midpoint of AD. Now by intercept theorem we have is this CG is equal to GB, but this is not possible because F is the midpoint over here and F and G, these are two different points. We are saying that this ED length and this EA length, these are equal to each other. AB line, EG line and DC line, these are parallel to each other. This is by our construction. Now if this much part is given to us, then automatically G is the midpoint of CB, and this thing is possible only if F and E, F and G we are talking about, these 2 points F and G, these 2 points they coincide, otherwise this is not possible. So we are saying that our supposition that G and F, these are two different points, or our supposition that EF is not parallel to AB is wrong. So we get that EF is parallel to AB. Now in the next question we are given a triangle ABC. This is a triangle given to us, and next thing that is given to us is that this E and F, these are the midpoints of AB and AC. We have joined these 2 points with this line EF, and we have drawn any line from A to the side BC. AL is there. We have to prove that these lengths AM and ML, this is any line drawn from A to BC. We have to prove that this AM and ML, these are equal to each other. To prove this, we are going to do the construction over here, and the construction is that we have drawn this line PAQ that is parallel to BC. These 2 lines we have drawn, these are parallel to each other. And now if we consider the triangle, we are talking about the triangle ABC. In this triangle we are saying E and F, these are the midpoints of the side AB and AC. So what we get from this is that this EF and BC, these are parallel to each other. By our construction part, this PQ is already parallel to BL. It means these 3 lines PQ, EF and BC, these 3 lines, these are parallel to each other. Now we are talking about these 3 parallel lines. One is this line PQ, second is this line EF, and third is this line BC. For these 3 lines, first transversal we are considering it is this AB, and second transversal we are considering it is AL. Now it is given to us that this AE and EB, these are equal in length. Then by the intercept theorem we are saying that this AM and ML, these are also equal in length, and this is what we have to prove. Next we are given a triangle ABC. This is a triangle ABC that is given to us, and the side AC is produced to E. This side AC is produced to E such that CE, this length CE we are talking about, this is half of AC. If D is the midpoint of BC, this D is the midpoint of BC, this is given to us, and ED produced, this ED, this is produced, meet AB at F. We have produced this ED, we are talking about this side, this meets B at F over here. Next we have CPDQ. We are talking about this CP and DQ, they are parallel to AB. This is given that this CP and PQ, these are parallel to AB. We have to prove that this FD over here, this is 1/3 of F. This is 1/3 of this length F. So if we look at the triangle ABC over here, we have D is the midpoint, this D is the midpoint of BC, and we are talking about this triangle ABC. D is the midpoint of BC, and these 2 lines, that is this AB and DQ, these are parallel to each other. So what we get is that Q is the midpoint of AC, that is these 2 lengths, these are equal to each other. Now we are talking about 3 parallel lines. One is this line AB, second is this line DQ, and third is this line PC. For these 3 lines we are saying this is a transversal and this is a transversal. Next thing that is given to us is, we have already seen is that these 2 lengths, these are equal. Then what we get is that this FD and DP, these are also equal in length by intercept theorem. Now in the question it is given that CE, that is equal to 1/2 times AC, and this 1/2 times AC means we are talking about the length CQ. We are saying, suppose this length is X, this whole length is 2x, then it is given that this length is also x, we are saying. Now if this length is x, we are saying, now we are saying that these two lengths are equal, these two lengths are equal, and this is also equal to this length. Now we consider the triangle. We are saying EQD. We are talking about this triangle. We will draw this triangle again. It is like this. This is QDE, and this line is given to us. This is C and P. Next we have is these two lines. These are parallel. This is x. Then this length is also. If these two lengths are equal, these lines are parallel. So what we get? P is the midpoint. It means this PE and DP, these are equal in length. We are saying DP and PE, these are equal in length. So if suppose this length is y, then this length is y, and this length is y. And this is what we have to prove, that this length FD, that is equal to y, that is equal to 1 by 3 times the length F, that is equal to 1 by 3 times the length 3.